In this video, we'll be talking about the case 2 of trigonometric substitution. So we now have here the integrand. For case 2, the integrand contains square root of a squared plus u squared. So although a squared plus u squared is what's given here, most of the time it will be u squared plus a squared, since we are used to having x squared written first. So with that, as a is greater than 0, we let u be equal to a tangent theta. Therefore, when we find du, that would be a secant squared theta d theta. And since u is equal to tangent theta, this implies that tangent theta would have the ratio of u over a. That's why u is on the opposite side and a is on the adjacent side. So by Pythagorean theorem, that the hypotenuse becomes square root of a squared plus u squared. With that, so that we are going to have an expression for a squared plus u squared, relating it to a, it becomes secant theta is equal to square root of a squared plus u squared all over a. Making square root of a squared plus u squared is equal to a secant theta. So let's try that in number 1. So in number 1, we have this. Let's drag it back because we need the guide. There you go. So from here, we have the integral of dx over x square root of x squared plus 9. So since we already know it follows case 2, we can let now a squared be, we now have a squared is equal to 9. So a equals 3. And we have u squared is equal to x squared, so u is equal to x. So therefore, we let x be equal to 3 tangent theta. So now, finding the differential, dx would be equal to 3 secant squared theta d theta. And as we can see here, you can actually automatically use this formula, or if you want to be safe, we can form our triangle. Let's do that. Oops. This. Let's form now our right triangle as guide. Oops. There you go. So according to this, tangent theta is equal to x over 3. So that's why this is the opposite side, the adjacent side, making the square root of 9 plus x squared, or x squared plus 9. So from there, the integral now of dx over x square root of x squared plus 9 is as follows. We have dx here as equal to 3 secant squared theta d theta. 3 secant squared theta d theta all over x, which in this case is 3 tangent theta. 3 tangent theta. And then your square root of x squared plus 9. That's not written here, but square root of x squared plus 9 would be 3 secant theta. So, let's write that down. So, square root of x squared plus 9 is equal to 3 secant theta. And we need to write it here also. So, 3 secant theta. So, we can cancel 3 secant squared and 3 secant. I'm going to have secant squared remaining on top. So, for this one here, we're going to factor out the remaining 1/3. We did that, so it's 1/3. The integral of this secant squared actually simply becomes secant theta d theta over tangent theta. So there you go. So before we do anything else, we need to try to manipulate this so that it will become a simpler expression. So we know that this is actually equal to 1/3 integral of secant is 1 over cosine theta. And tangent theta is sine theta over cosine theta. So therefore, this becomes 1/3 integral of 1 over cosine theta times the reciprocal of this, which is cosine theta, cosine theta over sine theta. There. So this gets cancelled. Oops, I forgot d theta. So what I'll be left is 1/3 integral of d theta sine theta. Or 1/3 integral of what is that? ln of sorry. We turn this first into a trigonometric expression with the trigonometric function on the numerator. So this becomes 1/3 integral of cosecant theta d theta. So therefore, the last thing to do is we need to convert that cosecant theta, and we know that it's actually one of the rules or one of the integration rules that 1/3 at the cosecant theta would then be equal to ln of absolute value of x squared plus 9. Sorry. Before we head to that, this is supposed to be first 1/3 the ln of cosecant theta minus cotangent theta. That's where he would usually relate the Pythagorean. That's the formula rather for the integral of cosine. That's a special formula. So based from here, we can then use our right triangle, right? Because cosecant theta is hypotenuse over opposite. Therefore, I'm going to have square root of 9x squared plus x. Then, if I'm going to have cotangent theta rather. For cotangent theta, it would be the adjacent over the opposite. Therefore, this becomes 1/3 the ln of absolute value of cosecant theta is hypotenuse over, since they're both opposite side and the opposite side is x, we just leave it as x. So I have ln absolute value squared of x squared plus 9, and then sorry for the long word, and then this becomes over 3, and since this is minus and they have the same denominator of not 3x, my bad. So since cosecant has something over x, this is square root of 9 plus x squared over x. Cotangent is 3 over x, so they can have together the ln of square root of x squared plus 9 minus 3 all over x. So we have number 2, the integral of x squared plus 4. Pause the video and try to see if you'll be able to answer this question. So I'm going to leave the rest of the solution to you for you to practice. So first, if we're going to do the substitution here, it's kind of easy that a would be equal to 2 and u would be equal to x. So we're going to let x be equal to 2 tangent theta. Finding dx, that would then be 2 secant squared theta d theta. Then, in our right triangle, so this will then be, there you go. So from there, we learn that if it's x over 2, this is the opposite. This is 2. This is the square root of x squared plus 4. So there you go. So when we do now the substitution, what will come out is, this is now the integral of, by the way, we forgot the square root of x squared plus 4 would equal to 4, 2 secant theta. So there you go. So now following this, what I'm going to have would be 2 secant theta and then 2, that becomes, the first one, this is this one here, so that's 2 secant theta. The next one is dx, and dx is this. That's why we have 2 secant squared theta d theta. So there. So if we're going to factor out the 2, that's 2 times 4, then combine everything here, that's secant cube theta tangent theta. So now this is what you would have to solve. And I leave that to you on how to solve that because that is already taught before in trigonometric integrals. So the what I'm going to give is the final answer already, which is x square root of x squared plus 4 all over 2 minus 2 minus square root of square root of 2 x square root of square root of 2 plus 11 all over 2 minus 2 ln of square root of x squared plus 4 plus x over 2 plus c. Oops, sorry. Let's fix that. Let's fix that. ln plus x all over 2 plus c. So there you go. That's the example for number 2. So now, as you can see, the three cases, the first two cases will actually have a similar pattern. We're just using different trigonometric functions. And it's the same for case number 3. For case number 3, we have the integral contains u squared, so that's an x squared minus a constant here. So if it's case 3, it's kind of similar to case 2, but instead of tangent, we let u be equal to secant theta. So this becomes du is equal to a secant theta tangent theta e theta. There. So since u is equal to a secant theta, it implies that secant theta is equal to u over a, making u the hypotenuse and a the adjacent side. So it becomes u squared minus a squared, the square root of that, for the adjacent side. So with that, I'm going to relate square root of u squared minus a squared and a to find a value. And since this is the opposite side, the adjacent side, so opposite over adjacent gives you a tangent theta, making square root of u squared minus a squared is equal to a tangent theta. So let's try to work on this in number 1 here. It's almost the same procedure. We identify first a squared is equal to 25, so a equals 5. Then we identify u squared as x squared, so u is equal to x. So from here, we can now then let x be equal to 5 secant theta. With that, dx will then become to 5 secant theta tangent theta d theta. And we're going to now let square root of u squared minus a squared, or in this case, square root of x squared minus 25 equal to 5 tangent theta. So, if we are to construct now our right triangle guide, here you go. Our right triangle guide here, here, and here. That becomes theta is equal to, this is the hypotenuse, this is the adjacent side, so this is square root of x squared minus 25. So therefore, by performing the substitution, I'm going to have dx is equal to 5 secant theta tangent theta d theta. There you go. And then x squared minus 25 is 5 tangent theta. So here we can cancel the 5 and then the tangent theta. What is left is the integral of secant theta d theta. And that would, this is a special formula, and its integral rather is ln of secant theta plus tangent theta. So therefore, from secant theta d here, we can get that it's x over 5 is equal to secant theta. Tangent theta is based from here, that will be square root of x squared minus 25 all over 5. Sharing again the same denominator, we can combine that in 2. This becomes the ln of x plus square root of x squared minus 25 all over 5 plus c. So there you go. So try to work now on number 2. Pause the video and try to answer number 2. I'm only going to provide that the basis for substitution, the substituted integrand already, and then the final answer afterwards. So pause the video and try to answer number 2. So I'm assuming already did. So let's have here our basis for the substitution. We have u squared is equal to 9, so u is equal to 3. Sorry, a squared rather. A squared is equal to 9, so therefore a is equal to 3. And then we have, based from this, we now let, sorry, I still haven't established u squared is equal to x squared, so u is equal to x. It's the only time that you say that we let x be equal to 3 secant theta. Finding the differential, dx is equal to 3 secant theta tangent theta d theta. So there. So we can already actually have square root of x squared minus 9 is equal to 3 tangent theta. But if you want, I do highly advise that you form your triangle guide. So there you go. So based from this, since x is equal to 3 secant theta, this is x, this is 3, that's why this is x squared minus 9, which we can use later on. So based from here, number 2, dx is 3 secant theta tangent theta d theta. X cubed is 3 secant theta, so it becomes 3 secant theta cubed. And then, lastly, for the square root of x squared minus 9, that would be 3 tangent theta. There you go. So if you're going to simplify this, I'm going to leave that to you. V1 over 27, the integral of cosine squared theta d theta, which the final integral in theta gives us 1 over 54 theta plus 1 over 108 sine 2 theta. Finally, the final answer would be 1 over 54 arc secant x over 3 plus uh, plus 18 square root of x squared minus 9 over x plus c. So, those are cases 2 and 3 of trigonometric substitution.